I'm back. So for today, we are going to solve this example. Let me read it first. 3,000 pesos is placed in an account at 5% interest compounded quarterly for 5 years. How much is in the account at the end of 5 years? Compound interest calculations take place every conversion period. Therefore, when using sequences, we take the number of conversion periods as our counter. Okay, so let's do this. Step 1, we need to identify the variable. Okay, so we need to let a sub n the amount in the account after n conversion periods. Okay, so this is our variable. We need to determine the amount in the account after n conversion periods. Okay, now let's move on. Step number 2. Step 2, identify what is being asked. So in this example, we want the value in the account at the end of 5 years. Since there are 4 conversions periods in a year, there will be, again, since we have 4 conversions, why 4? Because of the word quarterly. So meaning in a year, we have a conversion of 4. There are 4 conversions in a year because of the word quarter. So in a year, we have 4 conversions. Okay, but in this example, we will be having 4 conversions for 5 years. So what is that? 4 conversions and multiplied by 5 years, we have 20 conversions per periods, conversion period in 5 years. So with that, we are looking for, therefore, we are looking for a sub 20. So meaning we are looking for a sub 20, the amount in the account after 20 conversion periods. That is our step 2 again. Step 1, our variable is a sub n, where n is the conversion periods. And for step 2, we have 20 as our conversion periods in 5 years. That's why what is being asked is a sub 20. Okay, next, step number 3. For step number 3, we need to identify step 3. Identify the given values. So in the problem, as you can see, the yearly rate is 5%. So therefore, again, our yearly rate is 5%. your yearly rate 5%. And we need to find the rate per conversion period. So we need to divide it by I know 0.05 divided by 4. 4. So therefore, our rate per conversion period is 0.0125. With that in mind, we know that our common ratio will be 1 plus 0.0125. This is the rate per conversion period. So we put 1, that is the wholeness, right? Since we are talking about the total account at the end of 5 years, we must add them, the wholeness and the rate per conversion period. Okay. Again, the problem is how much is in the account at the end of 5 years. That's why we use addition. Addition. So with that, our common ratio is 0.125. And of course, our first term, we need to look for the first term, the value after one conversion period or one conversion period or quarter, 1 quarter. So with that in mind, our let's compute for the first term times 1.0125, that is 3,037.50. All right, that will be our first term. There's a point. Okay, next is, let's move on to step number 4. Step 4. Identify the series or sequence to be used. So in this example, we have a common ratio, therefore, that is a geometric sequence. Geometric sequence. And the formula for geometric sequence that we are going to use is a sub 20, a sub 1. Common ratio is the power of 20 minus 1. That's it. Now let's move on. Oh. Step number 5. Step 5 is our solution. Show the solution. So a sub 20 is equal to a sub 1, or common ratio is about 20 minus 1. So what our first term is 3,037.5. 1, our common ratio 10125, 20 minus 1, or 19. So our answer is 3,846.11. All right, so last step is step number 6. What is that? The final answer. The final answer, the amount The account after 5 years is 3,846.11. Okay, thank you so much for listening, and we will continue some examples to our next video. Thank you.